All right. Well, thank you everybody for joining us. Today's event is artificial intelligence and human consciousness, what computers can't know. And as we try to keep things here at our Ayn Rand Center events, I try not to talk about what Razi can't know or doesn't know. So I'm not going to chair this event. I'm only going to introduce our speakers. So our speakers, Lee Pierson will be presenting the topic. He is the director of the Thinking Skills Institute and a cognitive psychologist. He will be discussing the topic with Adam Reed, also a cognitive psychologist, and chairing the event is Ayman Osman, who is a programmer. I don't know if you want me to mention your employer, but he is one of the let's say founding members of the London Ayn Rand meetup, which since became the Ayn Rand Center UK. So, Ayman, I'll pass it on to you. We can begin.
Cool. So as we agreed, Lee will start us off, and at some point he'll hand it over to me to explain a little bit about what neural networks are. So hand it over to you.
And that will be very soon, actually. Cool. Okay, so let me start off. Thank you all for coming today on this strange topic. My discussion, at least, is not going to be technical. I'm not going to approach this from the standpoint of the nuts and bolts of programming. Ayman may have some things to say about it. Adam might, and we have a fellow who was in on the early days of this kind of research, Bob Stubblefield. But I think back in his time, they didn't use computers; they used rocks to do computation. Maybe that's wrong. We can ask Bob later. Anyway, so as I'm sure all of you know, there has been a resurgence in the last 5, 10 years, 20 years of artificial intelligence. Artificial intelligence historically has progressed in waves. There's a wave of enthusiasm, and then there's what they call the AI winter, when the things are cooled off, and then there's another wave of enthusiasm, and it goes back and forth over the years. And we're currently in a wave of enthusiasm, mainly driven by the programs the recent programs that use what is called deep reinforcement learning and neural net programs. Now, neural networks have been around for a long time, but they have developed to a point of usefulness recently, partly because the hardware is so much better now. And so, some of you, probably most of you, know that just this week it was announced that the program AlphaFold has basically solved, I don't know to what extent because I haven't read the original papers yet, but it basically solved the issue of how proteins fold, which has been a big issue in biology for 50 years. Biologists have been trying to figure out, exactly, because it's a very complicated three-dimensional issue, and how the various proteins fold is actually quite useful in understanding biological processes, and that may lead to some tremendous breakthroughs. So that just happened. That was just announced this week. So, and also over the last few years, the program AlphaZero and AlphaGo Zero, those programs have been in the news a lot because of the fact that they have defeated the best human players in both Go and chess. And I'll say something about the chess later. But this would be a good point, I think, to turn over to Ayman, who can give some kind of description. I don't know how much he wants to do, but a description, something about, without getting into technicalities if possible, but how neural net programs work. So Ayman, take it away.
Sure. And I'll be brief. So there's two aspects to neural networks. There's the internal structure of it. So I'll give you some pictures of what the structure of a neural network looks like. And then there's this process of so-called training or learning. So for the actual structure, I'll post a link and then I'll also share my screen so people can see. So I'm currently sharing a screen. what you see there is called a perceptron. It's also known as a neuron. And this is the basic building block of a neural network. So what you see here is it's actually quite simple. It's just something that has inputs. Those are the X's. The inputs are weighted. So the W's stand for weight. And weight is, you can think of it as giving more importance to certain inputs than to other inputs. And then there's some sort of function applied to these things, and you create an output. So for an example, you would have something like the inputs could be, the neural network that neuron or perceptron could be deciding whether you want to go to a concert. And the inputs could be, whether it's raining, whether it's, whether your partner wants to go, and whether there's good public transport. And the weights would be something like, well, whether it's raining or not is very important to me. And whether my partner wants to go is less important, and whether there's good public transport is less important. So there'll be some sort of threshold that you have to pass. And if you, by combining all those inputs, you pass some certain threshold, then the output would be a certain output. So that's the lowest level of a network. And the next level, there's only two levels really. The next level is just you combine those things into a layered network. So each node here in this network is one of those perceptrons. And as you see here, it's every layer will draw input from the previous layer. So the apparent intuition that you're supposed to have for this is that lower level layers extract lower level patterns from the data, and subsequent layers extract higher level patterns, and keep combining those things until the final output just combines very high level data. Whether or not it's not completely clear to me that that's exactly what's happening, but that is the sort of the way you're supposed to think about it. So I'll just stop sharing my screen. The other aspect of neural networks is the training. So the training is simply tweaking those weights. So those weights are those connections between the nodes of the network. And what you do in the training phase is you keep tweaking those weights until the output is the thing that you want. So the training data is like a picture of a cat with the annotation that this thing is actually a cat. And if your network classifies it correctly, it's good. If it's wrong, you keep tweaking those variables until you get the correct answer. So there's a lot of complications in that area, but I think I'm happy to go into more detail, but I think we can stop there. And if it's needed, I can go into more detail about those kind of things.
Okay.
Okay, so we'll keep you there ready. Oh, Adam, you want to jump in?
Yes, I do.
No. Okay, go ahead.
Because the title was What Computers Can't Know. And what I'd like to start out with, and by the way, thank you, Eamon, for mentioning Minsky and Tappert, since I was in their lab and I'm one of the collaborators on the book on perceptrons. That was very flattering. But now I'm arguing from the opposite side, which is that computers cannot know, and in fact, thinking of computers as knowing things is a category error, because knowing is necessarily an awareness of something that I know. And what does it mean for me to be aware of something? Well, here is a little ceramic bird, and I'm aware of it in the sense that I know it's there. And that's a relation between me and the ceramic bird. Without both of us in that relation, there is no awareness. Both the object of awareness and the person that's aware are needed for awareness to take place. Now, if I place the bird upside down, I'm still aware of it. But that brings to the point that awareness is much more complicated, because it's not only a relation between me and the object that I'm aware of, but also the entire environment in which I am aware of the object. Now, computers, number one, are not generally in relation with things. We use computers to arrive at some results that we consider informative and that may in fact enhance our knowledge, but they are not in a relationship with the environment and the objects in the environment in the way that an organism is. And that just my consciousness. It's axiomatic to me that I'm aware of things. As for the rest of you, that's not axiomatic to me, but since you are organisms like me and you interact with objects in your environment in ways that are similar to the way I do, I'm just going to induce the fact that you guys are also conscious. But what would it mean for a computer, some kind of assembly of digital parts or a process running on the computer, to be aware of things? And I don't know what it would mean. And as long as I cannot ascribe any meaning to the idea that a computer can know something, the whole question goes out the window. Now, a computer can be very helpful, just like a microscope can be helpful in extending the range of my awareness. And in fact, I've known electron microscope salesmen to say something like, I have an electron microscope here that can see single atoms. But I don't think he's using the word see in the same way that I'm using the word see when I'm aware of something by looking at it. It just means it can help me see things. So that's where I am with respect to, can computers know anything? Now, acknowledging that they cannot know, they can in fact help us know things quite a bit better than we could with our unaided brains. And in fact, the solution that Lee mentioned, the solution to the protein folding problem, is actually a complete solution. The team of researchers at DeepMind came up with a partial solution 2 years ago, and they got the biggest prize in the field for just this partial solution. And now 2 years later, they have a complete solution. Again, something that biologists and mathematical biologists and computer geeks like me have been working on for 50 years and haven't gotten much of anywhere and now they have a complete solution. So that's a good example of how computers can help us know. And
all right, Adam, can I stop you in a moment before you steal too much more of my thunder?
sure,
What I would like to do is I'd like to make, because you've made some excellent points, and I could make use of them, and they're in line with what I'm going to say. But I want to go ahead and make some general observations, and then get back to you, because I think you can comment on the folding. Also, I believe you want to comment on at least one of the language translation programs, which ought to be fascinating. But
yes,
let me just make, if you don't mind, let me make a few broader remarks, and also about get myself into this a little bit, and then we'll get back to that, if that's okay. So I wanted to say something about why I, as a psychologist, and not a computer programmer, especially, and I'm certainly an amateur in that field. Why do I have a special interest in this topic? I mean, it does have intrinsic interest. The fact that these programmers, coders, are able to do these wonderful things. We've got this solving of the protein folding problem is quite a wonderful development, and certainly the power of these programs has increased immensely over the years, because in my own experience with them is mainly in the chess area. Because I, at least when I was in high school and early in college, I was an amateur chess player. I played in some tournaments. I wasn't too serious, but I was let's just say a decent amateur player, not a master or grandmaster, but a good amateur. I did well in some tournaments. And when I was a student at Columbia, they had one of the best programs, chess programs in the world there, and I went up there and beat it to death. Just crushed it every which way. Now we've come to the point where I can't touch my cell phone. Playing chess, it's got a version of Stockfish, which is the best program of at least one type. And I have to turn down the power to have any chance whatsoever. They've gotten so good, and the neural net programs are amazing, not only because they're extremely good, but because they play in a very different way that is somewhat more similar to humans than the usual program. So that's part of my interest came in part from that, and just to reinforce the point that Adam made about that. When you're playing the chess program, or I know when I'm playing the chess program, that it does something really well, but in a sense, it's not playing chess, because, as Adam said, it's not thinking. The answer to the title question, what is it that computers can't know, is indeed they can't know anything. They don't have knowledge, at least not knowledge in the sense of the self-awareness that we know something. We don't have that. They could be said to have knowledge in the sense of knowing how to perform a certain task. Long ago, William James made a distinction between knowing how and knowing that and knowing how. And the knowledge, the explicit knowledge, conceptual knowledge, is knowing that something is true, and knowing how to do something is the procedural knowledge, as they call it now in psychology. William James and even Bertrand Russell made that distinction, and there's something to that. But at least in the knowing that sense, the computer doesn't know. When I play chess with the computer, or when I've done it, it doesn't know what a rook is. It doesn't know what castling is. It doesn't know what checkmate is. It doesn't know anything. And this became very clear in my mind back when I was maybe before grad school, at least in grad school. This is back in ancient times, but it was well known to my professors that computers don't know anything. The comparisons they would make with, it's like an abacus. You can use it to do computations, but the abacus doesn't know anything. At one point, when I was a grad student, a professor from Carnegie Mellon, which was another one of the temples of artificial intelligence, or what they called it computer simulation in those days, besides MIT, is Carnegie Mellon. Herbert Simon, Nobel Prize winner, was the big professor there. Anyway, a woman from Carnegie Mellon, I can't remember her name, came and gave a talk at Cornell when I was a grad student on a program that she had created, she and her students, for solving, I guess it was first year physics type problems from the textbook problems in forces and vectors and speed, velocities, mechanics, I guess was mostly mechanics. Anyway, she had a program that, as she put it, simulated the problem solving processes of solvers of physics problems. So at the end of the lecture, I asked her, couldn't someone sit down, someone who knows nothing about physics, nothing whatsoever about physics, sit down and then, at least in principle, hand simulate this program and solve all the problems that this program could solve without understanding anything whatsoever about physics, no knowledge or understanding about physics. And so that therefore, whatever else this program is doing, it's not giving us any insight into the problem, into the actual solution processes that humans do, which depend on understanding concepts, conceptual understanding. And I think that's true. By the way, you may note that that's that those of you who know about this, it's similar to John Searle's Chinese Room, but I actually like mine better than his. And it just goes to show if you think of something, you should publish it. And I didn't do that. Anyway, so it is clear, I think, that computers whatever they do, they don't have any understanding. They don't grasp. They do something, and therefore they're not intelligent. There's no such thing as artificial intelligence. What there is those AI programs can perform things that we might have thought, or we once thought required intelligence, but they can do it without intelligence. That's how I view the chess situation, is that they're able to do something that's at least simulation of playing chess, but they do it in a way that doesn't actually involve intelligence. And they do it very differently. The usual chess programs, like Stockfish, not the neural net programs, but some of the more traditional ones, look at 80 million chess positions per second. It's an unimaginable number to look at. 80 million per. I can tell you, I'm not even close to the world's best player, but I don't think this is much different even for the world champion. I don't look at anything like 80 million positions per second. Maybe I might look at 1 per second, and maybe less sometimes. So the process is totally different. But there is no doubt that there is a tremendous success in the field, and I cheer them on. This is another reason I am interested in this. I cheer artificial intelligence. I want them to do as much as they can to explain how automatic actions, or to produce automatic actions. Intrinsically, it's wonderful for all of us, but also for me. I think that's effective support for my contention that consciousness is all about volitional action, and that automatic actions are controlled entirely outside of consciousness. That's those of you who listened to my fairly recent lecture on consciousness as the manager of cognitive activity. I made that view. I presented that view there. So I cheer them on, and I hope they continue to make that progress. But I do think that there's an in principle limit to what they do, and it has to do with the fact that these processes are deterministic. And so I'll get back to that in a moment. I wanted to say a word about why I think I can undertake this kind of critique, even though I don't have the deep knowledge that Eamon has or probably Adam has of this, well, either one of them, of the computational details. And that's because I'm not trying to here today, and we're not going to try to go over all the possible critiques that can be offered for AI, some of which are offered by computer scientists themselves. But I'm trying to get to essential, or really fundamental, that underlies most of the others, and it's going to have to do with determinism and free will. So it's a psychological and philosophical point. And what I want to talk about here is as much about what we can do consciously, what we humans can do consciously, as it is about what AI cannot do without consciousness. Now, by the way, there are existing critiques of AI out there that are really pretty good or interesting. And over the years, there have been a large number of critiques that are worth looking at. But I don't think they get to the fundamental. I've never seen any of them quite get to the fundamental, because very few current intellectuals, either philosophers, psychologists, or computer scientists, very few of them believe in free will. And free will, I believe, is a fundamental point of departure for showing the in-principle limits of what computers, what AI or computers in general, or let's use another term, what algorithms can do. You know, an algorithm is a procedure for achieving a certain result. It's a set of steps, or a process, a set of steps for achieving a result that, if you follow it properly, leads to a definite result. And we all learned algorithms in school for example, dividing one number by another. You know that you can divide numbers with arbitrary numbers of digits, and that you know how to do it, and you know that if you perform the process correctly, you will get the answer. It's guaranteed, and it's, as it were, algorithms are, as it were, deterministic processes. And computer programs, so far as I understand them, are deterministic in that way. I suppose you can add indeterministic elements to a computer program, random elements. That doesn't matter, and I'll get back to that later as to why. But the point is that, in principle, there is a difficulty with algorithms, or it's impossible for algorithms to have understanding or knowledge. And that's underlies many of the critiques. Nowadays, I'd say the most common and important critique of AI is that it's the word they use is brittle. As one guy puts it, self-driving cars are brittle. The programs are, because they're hoodwinked by mere stickers, bumper stickers, into driving on the wrong side of the road. These programs, which are also quite amazing, we're not using them right now because, among other things, but perhaps most importantly, they cannot handle small deviations from what they're trained to. And humans, the flexibility that you need to handle the small deviations from what you've learned on is exactly what's given to us by free will and by conceptualization, conceptual thought and understanding. There's also the critique by Judea Pearl, that's worth mentioning now, we come back to, that the AI programs do not, I was going to say grasp, but they don't grasp anything, as we've already said. They don't understand. They don't deal with causation. They're really dealing with correlation. And that's a serious problem. And Judea Pearl has done some work. He wrote a book on it, which I read. I could not decide that, I could not judge myself anyway that he has solved the problem, and I doubt it. I doubt that he solved the problem because, in my opinion, our understanding of, as humans, of causation is grounded in our possession of free will. You learn about causation, and I'm not the only one who thinks this. You learn about causation by causing things. When you push a ball, you know you're the cause of the pushing of the ball because you pushed it. You're the cause. You volitionally decided to do so, and that makes a difference. So lack of volition is an in-principle limitation. Now, there are some critiques from the objectivist standpoint, which I've heard from many places. There was actually a very nice discussion of critiques from an objective perspective on Harry Binswanger's discussion list some months ago, and they are quite valid. They include pointing out that intelligence, or human intelligence anyway, but intelligence, let's say intelligence, exists only in entities who are living, who are goal-directed, who are value-motivated, who are conscious, including self-conscious, and are volitional and conceptual. All of those things are legitimate points brought up by objectivists and critiques I have heard or read. But I think they can be reduced, in my opinion, those critiques can be reduced to the possession of consciousness and volition. Now, that's probably going to be controversial. I don't think everybody will agree with me, but let's take the fact that we're dealing with living beings. That's one reason. Well, living beings, I'm not a vitalist. I think that life per se without consciousness is ultimately explainable in terms of physical processes. And so I think that that's in principle anyway, at least in principle, could be simulated by computer programs. Computer programs can simulate life. Now that's very complicated, but if they can simulate the weather, which of course there are limits on that too, but let's not get into climate change. They can attempt to simulate weather. They could attempt to simulate life. I would argue that it's impossible in principle to simulate cognition. You can't do it because the computer program is an algorithm and it has the limitations, which I'm going to describe more momentarily. And I'd say the same thing with goal-directed. I think you could possibly write programs to be something like what plants do in their goal-directedness, not what conscious goal-directedness. And same with values. You could write a program that simulates that, but not the conscious aspects. I think it's consciousness that really matters in this connection. And it's, in my opinion, it's volition that makes consciousness important. So there's the fundamental reason that AI has a very definite limit and can't know anything is lack of free will. That's the fundamental, in my opinion. That's going to be, maybe people will argue otherwise. But many of the critiques, many of the valid critiques are ultimately grounded in the issue of determinism versus free will. Okay, so let's go ahead and talk about that argument, which many of you know, probably most of you have read. Well, I don't know this audience, I'm not sure, but many of you have read the argument that's called in objectivism, the contradiction of determinism. The original source of it in the literature is an article in the Objectivist newsletter by Brandon called The Contradiction of Determinism. But it has also been discussed in OPAR. Ben Baer wrote an article recently on this, that at least in part was on this argument, not entirely. It's in other sources. But historically, it's been all over the place. There have been many, many versions of this argument. Objectivists often don't realize that. It was not invented by any objectivist. It was invented perhaps in its first form, perhaps by Epicurus. And there is a version of it in Immanuel Kant. And there are several versions published in philosophical literature in the 50s and 60s. Here's a short version, a really short, perhaps the shortest, of the contradiction of determinism argument that comes from the philosophically minded biologist J.B.S. Haldane, was a British biologist who actually was a Marxist, so it's kind of funny that he made this argument. And I understand he later repudiated, but anyway, here it is in the short form. Haldane says, "It seems to me immensely unlikely that a mind is a mere byproduct of matter. For if my mental processes are determined wholly by the motions of atoms in my brain, I have no reason to suppose that my beliefs are true. They may be sound chemically, but that does not make them sound logically. And hence, I have no reason for supposing my brain to be composed of atoms." That's where the contradiction comes in. So that's a pretty short form. You might get something from that. He then goes on to say, by the way, that in order to escape from this necessity of sawing away the branch on which I'm sitting, so to speak, which is exactly what you do when you deny free will, I am compelled, interesting he uses the word compelled, I am compelled to believe that mind is not wholly conditioned by matter. And that comes from J.B.S. Haldane's article, When I Am Dead. I don't know where he got that title, but the title is When I Am Dead. Anyway, there's a long history of debate. Actually, I shouldn't put it that way. The argument's been made many times, and there are a few rejoinders to it here and there from philosophers and others. But for the most part, the argument is ignored. Most philosophers just don't take it seriously. I remember when I was a grad student at Cornell, when I wasn't playing chess, I had there was a guy who was I didn't play chess at Cornell very much. There was a fellow who was a philosophy postdoc who later became a fairly well-known philosopher of science. Should I mention his name? Anyway, his name is John Heil. But what he told me about the argument, when I mentioned this argument to him, he said, "Oh, isn't that a joke? Isn't that argument just a joke?" So it's not even considered seriously. It's kind of strange. So the people that believe it strongly, and people that don't believe it just tend to think it's a joke. This argument does have a certain rationalistic feel to it, because it's a kind of a self-referring argument. Often has that feature. But anyway, let me give you another example of it. I'm going to skip some stuff here and I'm going to go to another discussion. I want to read you a brief discussion from Harry Binswanger's book, How We Know, which I hope most of you have, because this is a more modern version and a more, I'd say, convincing, perhaps, version than Haldane's. Here's Harry's version. Logic is a process that adheres to reality by considering all and only the evidence. But a deterministic mind would output, quote unquote, whatever was necessitated by the biased set of material, real or imaginary, that the determining factor permitted entry into its consciousness. A deterministic mind would be operating under constant censorship. Stop there for a second. The word censorship just leaped out in my mind. Is obviously he's using this in a more non-literal sense than Ayn Rand uses the term censorship, but since that's come up in discussions recently. But anyway, okay. Deterministic mind would be operating under constant censorship. Thus, a deterministic mind would be in the situation of a man forced at gunpoint to read aloud what is written on a piece of paper shoved in front of him. His utterances in that case would be cognitively valueless. Suppose a bystander asked the victim, "How do you know that what you are forced to say represents a valid logical identification?" The gunman writes something on a piece of paper, shoves it over his victim, and orders him to read. "I know it because ... It doesn't matter what the next words he reads are. It is still without cognitive content for the victim. That is the dilemma that a man would always be trapped in under the assumption of determinism. The concept of logic cannot be applied to a deterministic consciousness. Logic requires independent judgment, independent of any prejudicial, potentially censoring factor. The volitional ability to function rationally is required to attain that independence. And here's a really important part. Free will means having the power to choose to consider whatever is relevant, and hence to obtain objectivity. That's the key sentence in the whole thing. Now, let me frame this argument in terms of, against determinism, in terms of our current discussion, by thinking of deterministic factors as programs that control one's thinking, or algorithms. You can use either word there, I think. That programs that can and do operate without regard to the requirements of objectivity. Now, the allegedly programmed nature of human cognition is widely accepted in both current cognitive and evolutionary psychology as a fact that we're programmed, and they recognize that it's problematic for the validity of human thinking. As, for example, you can see this as described in Daniel Kahneman's well-known book, Thinking Fast and Slow, where it talks about all kinds of biases. And when he is asked, as he has been in interviews, what can we do about the biases? I heard him say more than once that he says, Kahneman says, I've studied this stuff for many, many years, and I still make the mistakes. And he finally appealed. He said that the only thing you really can do is you can hope that certain human institutions, social institutions, like the way science is performed as a social enterprise, that will solve the problem and get rid of the biases. But of course, social institutions have their own extra biases built into them. So that's not really any answer.
Lee,
Now,
I would
yes.
like to propose an alternative.
Yes.
There is no such thing as a seat of consciousness in the brain or in procedures performed by the brain or by the nervous system. I regard consciousness as a relation between the organism, which of course includes the nervous system, but is not limited to it, and the entire environment in which we live. This leads to much more complicated interactions than would be possible on the idea of just the brain running a program. And while it is very difficult, given the complexity of those relations, to come up with the equivalence of the arguments you just made, I suspect that the answer, when we eventually find out what it is, involves much more complex relationships among relationships than would appear from those relatively simplistic argument from algorithm.
Yeah, of course, as you might expect, I'm sympathetic to what you're saying about consciousness and its relation to the environment and its relation to the body, so that it's embodied and it involves our actions, since that's very much what my old mentor Gibson advocated. However, I would say that I still think we can, a couple things. We can still attack the issue of can computers have knowledge by pointing out that algorithms as deterministic processes cannot lead to knowledge. But I'd also say that even in, no, I don't, you're right, it's complicated. No matter how complicated it is, I think fundamental to human consciousness, the knowledge that human consciousness is able to have is volition. Volition is fundamental. I don't think, I really believe that there's no cognition without volition. And in the even at lower levels of cognition, our relationship to the world is given to us in a significant part by our actions, our intentional volitional actions that we take in the world. It doesn't just come to us. Now, on the other hand, there is another hand of this with regard to conscious experience, the actual, what it feels like to have pains, or what it feels like to suck on a juicy orange. This stuff that the some philosophers call qualia. That stuff, there is such a thing as that stuff, conscious experience. And I would say, maybe you'll disagree with this, that the immediate cause, the proximate, that's the word, I guess, proximate cause of conscious experience is neural activity, is the activity in the brain. Now, there's a whole lot of other causation involved, and there's a big feedback loop, and it's complicated. But I think we know that every conscious experience results from some kind of neural activity on a moment by moment basis. If you destroy the neural activity, you destroy the consciousness. I'm talking about this when I'm talking about consciousness here. I'm talking about what philosophers refer to. Most of them are bad philosophers, but as qualia, the stuff of the stuff of our experience. That stuff, and that actually matters too. So I agree with you. I still think that we can profitably criticize artificial intelligence in terms of, well, let me put it this way. The way I would apply the contradiction to determinism argument in brief, because I'm going to try to shorten all this a little bit, given that time is moving right along for us, and you still have things to say. I would shorten the argument of determinism, or just how it applies in this case, is an artificial intelligence program, an algorithm, cannot override itself when it would need to in order to correct faulty programming. A program, the new programs anyway, can modify themselves. They're self-modifying programs, but they can only self-modify in accordance with the programming. And that's the difference between us and them. We, having free will, can go beyond any kind of programming that we might be subject to. And I think we are subject to programming by schools, quote unquote, analogously, from our schooling, from our upbringing, from parents, maybe even in some cases genetically. To me, that's possible in some primitive cases. Whatever it is, the point is that we have free will and we can override that, and they can't. They can't. If they have some of their biases, biases are inherent in pretty much any algorithm, and some of them they would not be able to eradicate because they're part of the program that does the eradication, or that would be operating it. So that's the problem. The program cannot, it can modify itself, but it can't override itself. Whereas volition enables the possessor to go beyond the programming, to get outside the box of any possible programming. And that's interesting to me because that's exactly what I teach the students. That's a reason why this whole thing is of some interest, is I teach what I often call key issue thinking, which is how to focus on the issues, which I call the key issues. The issues that must be resolved for keeping your thinking on track to its goal, when what comes to mind automatically, in an algorithmic sense, what comes to mind automatically, or by just trying harder, has left your thinking stuck or sidetracked. And we know this happens. This is an empirical fact that people get stuck or sidetracked when they're just running on automatic, or even when they say, I'm going to try hard. I see it in students all the time. A lot of students think if they just try harder, they will get it. They'll solve the problems. They will understand everything. It doesn't always work. It doesn't work that way. You have to use your free will in a particular way.
Let me bring in what I think is a very relevant fact from human paleontology, which is that the anatomically modern human brain case, which as far as we know, always contained a brain organized the same way as ours and permitted operations that people would normally do with such brains, is 300,000 years old. On the other hand, the use of concepts to do things that are not possible without conceptual cognition, such as a bow and arrow or a boat, only date back 50,000 years. So for the first 250,000 years, human brains just executed whatever they inherited from more primitive primate brains, like trial and error, or trying to kill whoever has something that you want. And it is only in the last 50,000 years that humans, by some exercise of free will, develop the ability to think and act conceptually. So I think that free will event must have been very rare and very unlikely, but we are very happy that it did happen. And
I agree with that.
I think that yes.
I was just going to say that I certainly agree with the general thrust of what you're saying. What I would add to it is evolution, and this is for, I think, useful for objectivists to keep in mind. Evolution does not work by suddenly something jumps out of Zeus's forehead into the organism. Free will did not all of a sudden erupt 50,000 years ago. I don't think that's what it had. Like all attributes, all evolved attributes evolved through transitional forms. That's just the way evolution by natural selection works in those kinds of relatively small steps. So I think there was some kind of more primitive form of free will before the conceptual form. I think this, Adam. Before the conceptual form developed, whenever it was, it might have been 50,000 years. It's a little hard to tell to be sure from the fossil record what happened, exactly when. But okay, in any case, I think it evolved over a longer period of time, and then we reached a point where we could. I think the point where we became conceptual is when self-consciousness developed. I think that's a key element that allows us to control the elements, the combination of elements in our thinking. And I don't know how long it takes to develop self-consciousness, but again, my point is that it's shall we say, a gradual process, as evolution always is. It's not just all of a sudden. There we are with our power of conceptual thought. I wanted to give an example. I mean, I was talking about what I call key issue thinking, which really has three elements. One is introspection, self-awareness. I think that's something that also it's hard to see how a computer, well, not having awareness, it's hard to see how it can have self-awareness. But I think the ability to examine your own thought process, to identify the gaps in your thinking, the key issues in your thinking that you need to direct free will attention to, is crucial, and it's volitional. Then there's that's one step. Recollection is the second step. That's the intentional or volitional recalling of something. Bringing material to mind by volitional effort, as opposed to just going with whatever comes to mind automatically. And then the third one I refer to as imagination, which is the process of combining the elements, the mental elements that you've activated and brought to mind, combining them in new and different ways. And I wanted to give a little example for you to think about of how this works. Like I've done in other lectures. This time, rather than going for problem solving, I'm going to go for comprehension, which is a basic cognitive skill underlying all others. And comprehension is exactly what computers can't do. They can't understand anything. And I decided that a little joke would be a good example for comprehension. Shoshana is putting her hands over her face for some reason. Anyway, I have a little joke. It's not so important that you laugh or anything. This is a joke about logic. This is a logic joke. But just, listen to the joke and see what you get out of it, and then we'll discuss it. Okay, here goes. 3 logicians walk into a bar. The bartender asks, Does everyone want beer? The first logician says, I don't know. The second logician says, I don't know. The third logician says, yes, please. That's it. That's the joke. Anybody get that joke? I had to check the chat and see if anybody, if I can do that. See if anybody. Old joke, says George P. Yeah, it's an old joke. I didn't make it up. It's an old joke, but it's a good oldie but goodie. I like it. Anyway, if you didn't get the joke, odds are it's because something, some key issue of understanding slipped by too quickly in your thinking. That's what happens that causes trouble, is things slip by too quickly. And I don't think there's anything analogous to this phenomenon in computers. But for humans, this is a very important aspect of focus. I already, in another lecture, I quoted what I said was, I thought Ayn Rand's most important statement that she never herself published was that focus involves slowness. Stephanie says, why do the first two say, I don't know? Yeah, okay. So there's a couple of cases where there might be key issues. I think one of them is with the term everyone. That, you have to, if you think about that for a moment, that means precisely the three people that came into the bar, the first, the second, and third logician. And that might slip by too quickly. And if it does, you're going to be lost. Another thing, and maybe this is what Stephanie is referring to, I don't know. When the first logician says, I don't know, you might need to think a second about, what does that mean, that I don't know? Understand that statement a little more than what happens automatically. And if you do, you'll get around to thinking, well, he doesn't know. He certainly knows whether he wants beer or not. He doesn't know whether the other guys want beer. And if you've understood everyone, you know that if he doesn't want beer, he could say that not everyone wants beer, because of everyone includes all three of them. So I don't know. I should probably explain the joke further than that. But anyway, the point is that you get a joke because you understand it, and if you don't understand it, it's because key issues slip by too quickly. And I think that's the case in all kinds of yeah, it's more of a puzzle than a joke, says Stephanie. I guess you could say that. Anyway, it happens in comprehension all the time. All forms of comprehension is that if you get something, you see how all the elements work together to arrive at whatever the conclusion is. If you don't, something slipped by too quickly, or more than one thing often slip by too quickly, and that's exactly what you need to be able to do as a volitional being, as slow the process down, identify that key issue where your gap in thinking is, activate some knowledge to deal with it, and then you can go from there. All right, I wanted to, I'm going to skip some little bit here, but I did want to talk about imagination a little bit, which is, again, something I don't think computers can really do. Imagination is a volitional process of combining mental elements that weren't combined in that way before. And it's imagination is very important in cognition.
Yes, and it touches on machine translations. So,
all right, let me just
give
this example.
Discuss this.
Let me just give this example, and I'll turn to you on that one. But let me give this one quick example, and I will turn to you on just that. That's good. I'm glad that's true. Here's an example of using imagination to discover, to identify what is essential or what is important. And I think that's, in my opinion, that's the only way to do it. There is no other way I know of to identify the essentials of a situation other than by an imaginative process. And this one is my favorite passage from Introduction to Objectivist Epistemology by Ayn Rand, where she's talking about, well, I'll just read it. She'll tell you. She can tell you better than I can. Metaphysically, a fundamental characteristic is that distinctive characteristic which makes the greatest number of others possible. Epistemologically, it is the one that explains the greatest number of others. For instance, one could observe that man is the only animal who speaks English, wears wristwatches, flies airplanes, manufactures lipstick, studies geometry, reads newspapers, writes poems, darns socks, etc. So she's giving you a number of concrete things that are true about humans, about what they do. Now, then she says, none of these is an essential characteristic. None of them explains the others. None of them applies to all men. And now she is going to explain, how does she know this? How do we know that this is true? She says, omit any or all of them. Assume a man who has never done any of these things, and he will still be a man. So she's using the technique, I'm going to call it mental subtraction. You mentally remove the characteristic to see whether it really matters to what the thing essentially is. And they said that wouldn't. And she goes on to say, but observe that all these activities and innumerable others require a conceptual grasp of reality, that an animal would not be able to understand them, that they are the expressions and consequences of man's rational faculty, that an organism without that faculty would not be a man. Mental subtraction. If you do that, and you will know why man's rational faculty is his essential distinguishing and defining characteristic. Now, in order to do this kind of thought experiment, and the thought experiments are fascinating, but we'll have to talk about them more another time, I guess. Grasp of the relevant causal, in order to do a thought experiment, you have to have a grasp of the relevant causal relationships involved with the attributes and the entities involved. And this again is something that I don't so far computers or AIs are not good at. And for us, this grasp, as I say, I think it's based on volitional experience. Okay, the next thing I want to talk about is skipping over some things would be some implications for employment and education. And someone has raised a question about cognitive biases you want to talk about, but I think I should turn over to Adam here, because this is a good place, I think, for him to talk about what he has to say about language translation. So Adam, where are you? There you are.
Okay, I'm here. And if you remember from the early days of Google Translate, it was awful. No human being would translate that way. And one could immediately tell that there was a fairly crude algorithm at work. Now, today, there is a service based on deep learning called DeepL. The L may stand for learning or linguistics. And if you do your translation between two languages that you're familiar with, let's say for me, those might be English and French, they come out as the product of a very intelligent, very well-educated, and very fluent speaker of both languages. In other words, they're about as perfect as you would expect a professional translator to produce. But there's an interesting sideline on that. And that is one of the languages that you can get translations to and from is Polish, which I'm also familiar with. And if you translate from French to Polish or English to Polish, you again get a very high quality, intelligent translation. But try it the other way. And that's where it fails. and it fails on something very closely related to humor, which is that in Polish and Czech, the West Slavic languages, those languages are productive, which means that in order to convey your idea exactly, you need a new word. The language has a productive syntax for producing a new word to fit the situation. And the word is sometimes humorous, sometimes it has pathos, poetry, it has qualities that a fluent speaker of those languages can produce on demand when they need it. And that is where Deep L completely fails. And just a few days ago, I was reading the memoir of a doctor stuck in a hospital that hasn't changed much since the communist times, because the Polish government was spending money on other things and the hospitals were not privatized, they were not improved. And so here he is, and there is nothing he can do about the COVID-19 patients who, without the proper treatment, which would have been available in a Western hospital, without that proper treatment, they are going to die. And the rooms they are in, he invents a new word, umieralnia, which means where people die on purpose. It's a new word, so it hasn't been encountered in any of the back propagation training sessions for the DeepL translation algorithm. And the back translation from Polish is a complete failure. Now, I'm sure that if you're fluent in English, you know many words that come from Polish or Czech when somebody needed a new word and created one. For example, robot is one such word. Somebody needed a word for a device that could do work that humans do for us, that is not as an independent conscious entity, but just work for us more or less as a slave would work, except that it's not a slave. There are no ethical problems. It's just manufactured on the assembly line like any other product. And hence we have the word robot, which we use all the time. We even have derivative words like robotics. And it's at that point that DeepL fails. Now, I'm sure by now robot is widespread enough, but when it was first used in a book, DeepL would not have been able to handle it because it has to do in very deep ways with the human capability for irony. Umieralnia is a very ironic word. It includes the part about a room being there on purpose, and yet the purpose is only for people to die. And that seems to be, at this moment, irony, humor, pathos are all things that are still not within the realm of what a deep learning machine can learn.
Okay, aren't we still back to the same original point that even if they can perform extremely well in translation, it doesn't mean they understand anything about what words mean. There's no actual understanding.
Yes, and it's at that point where you need actual understanding
Yeah.
that they fail. And the actual understanding, let me bring it back to something I said earlier, is not in the words, it's not in the text, it's not in what is being translated, it's in the relationship between the speaker and the listener and the world around us, the objects and the objects in our environment that are really what we're conscious of.
Yeah, and again, I would stress the tremendous importance of our own activity of orienting, moving, grabbing things, feeling things, walking around things. All that sort of activity is crucial in establishing and maintaining that contact. That's what I learned from J.J. Gibson, actually.
Yes, but Harry Binswanger has a very good example of an experiment where you yoke two kittens together so that one of them can move freely and the other one is just yoked to follow the motions of the other. And the one that is able to move freely and get the learning by back propagation of the neural networks in the brain so that they are aware of moving in the environment. I wouldn't say aware in the conscious sense, but they can incorporate into their reactions the feedback, the back propagation of what happens when you act on objects in your environment and you change the relationships between yourself and those objects and among those objects. And that is absolutely crucial to the development of visual awareness. Without it, the actual neural networks in the brain that are necessary for it just do not develop.
Okay, let me. I want to. There are probably lots of questions for people that people want to discuss, and I may have a few myself to ask myself or Adam. So let me just briefly mention one last topic area, or it's two areas maybe. Just wanted to make some very brief comments about, namely, implications of understanding the limitations of artificial intelligence, the respects in which, the in principle limitations, what implications that might have for employment, human employment, and education. And of course, these are big subjects. I just want to drop a couple of things out here because a lot of people are worried. Well, some people are worried that AIs are going to take over the world. They're going to enslave us. I don't really see that as an issue unless somebody can figure out how to give AI systems consciousness and free will. And of course, nobody has the slightest idea of how that could even be possible outside of the living systems that we now know have it. But if they can do that, so that's fine. But I don't. We're not even. Nobody's even going in that direction, as far as I know. I'm not actually worried about that problem. There's also the problem of unemployment, that robots are going to put you out of business. And if they ever can get the self-driving cars, they actually can get that to work, that the Uber drivers will put out. And, this is the same. I think it's not really different from all the other cases in history where people are put out of employment of a certain type by machines, but the overall employment is not decreased, it's increased, and the productivity of labor is increased. So it's actually a good thing. It's true that some people may have to change their jobs, and that's happened before, but there's no reason to believe, as a matter of economics, really, there's no reason to believe that that people will lose jobs, that there will be no jobs people altogether. Now, what kind of jobs might come about as a result of what kind of new jobs might come about as a result of developments in artificial intelligence, so-called? It's hard to project. It's hard to imagine what those might be. But one area would be what we call, some of the chess players call centaurs. That's when you have a computer chess player and a human working together, and the human's in charge. The thing is, it is by the nature of a human having consciousness that the human should be in charge. The computer, in my view, is kind of like an external subconscious, an external subconscious. Ayn Rand made the comparison of the subconscious to a computer. And as a very rough comparison, I think that's fine. I don't accept it as being accurate in detail, but something. And I'm just going the other way and saying we can compare computers, at least in the artificial intelligence world, to versions, to our subconscious. It just adds more subconscious, automatic, as it were, processing capability, but it still needs management by a human. So I think that the future jobs will involve managing AI systems and using exactly the thought processes that computers can't do, what I call key issue thinking, the ability to go beyond the automatic, to identify where the automatic processes get stuck or get sidetracked, and to go beyond them is exactly what humans can do. And that's exactly what I teach. I think that should be taught in school more, which means people should be taught, especially introspection. I guess I made this point when I gave my lecture on introspection, so I'll make it again. I think introspection is the cognitive skill, the most important cognitive skill that is not taught explicitly in school anywhere. Implicitly it is, and it should be. But also, more generally, I think the other skills of recollection and imagination that I put under the general category of key issue thinking, all of those should be taught in school for the purposes of being ready for future employment opportunities. Obviously, there's much more could be said about this, but let me just say that. Just make two more quick comments. Computers, I'd say, are by nature second-handers, not by volitional choice, and it's not a matter of morality, but they're programmed. That's what it means to be a second-hander, is to accept the programming that you get from whatever source uncritically, and that's the nature of any kind of computer program. But of course, students should not be second-handers. They should develop the thinking skills that enable them to go beyond that. And then one other thing I skipped by, I just wanted to mention, is that I did refer to this briefly. If you have an algorithm that somehow builds in randomness, maybe quantum computation does this in some way, I don't know, but it doesn't have to be that. If you build in some random element, that does not escape the contradiction of determinism, because the contradiction of indeterminism is the same argument. That is, if you are under control of non-rational causal factors, you don't have knowledge. If those causal factors happen to be random, the random factors are not rational factors. So again, you cannot have knowledge, or you cannot be objective. in your judgments of knowledge. So the contradiction of indeterminism is the same, and it doesn't matter if you bring in some kind of quantum mechanical thing or some other source of indeterminism into your AI system. That doesn't help the issue that I've been raising. Okay.
Okay,
let's go ahead. Let's see.
Let me
Yeah, go ahead,
interject something on education, which is that education has changed, and I think irreversibly, because we're now at a point where a 13-year-old kid in China or India is not forced to be in a social environment anymore. They are expected to do their work from home, but if they're from home, they can look things up on a dozen online encyclopedias, and if something interests them, they can follow the link to an MIT lecture or a Stanford lecture on whatever interests them. And fortunately, in my own life, I did have a year like that where I didn't know the local language. And so I was given a free run of the libraries. Now it's not just your local libraries, which even in a city like Paris have certain limits. Now is the videos of lectures from every university in the world. And there's no way to stop it, because what are you going to do? Force the kids back in the classroom? That's not doable anymore. So the idea that a student's learning will be programmed and controlled without the student's own free will, that's finished. We're entering a world in which people can actually live their individual curiosity and free will, and that's going to be a very different world. And my biggest regret is our life extension technology is not up to giving me another century in the new world that we are entering.
Well, you're still alive, Adam, so stay that way as long as possible. And as you know, the life extension problem only has to be solved at the rate of more than a year per year to keep us going. So it doesn't have to be solved all at once. And I still have hope for us. There's still hope for any of us on this call. As long as you're alive, you still have hope that we'll be able to go forward. There is some life extension technology you can take advantage of now, but that's another discussion.
But the real thing that really interests me is that some 14-year-old hacker in Nepal or Sumatra or someplace like that is going to get access to a deep learning network somewhere and use it to solve the problem, because deep learning already has a record of solving problems that 50 years ago would have been considered unsolvable. And while respected, degreed, credentialed scientists are not necessarily going to go and hunt those unexpected problems.
Yeah.
The kids
That's true, but I
would to do it.
I would say that the protein. I'm going to go out on a limb here because I'm not sure this is right, but something like the protein folding problem is a fairly well-defined technical problem, and it's just so complicated. It's sort of like applying quantum mechanics to atoms bigger than hydrogen. It's not a matter of an in principle difficulty. It's complicated computationally. Life extension is not exactly that sort of thing. It's not as well defined a problem as to what life. We don't even know exactly what life. We still don't even know exactly what life extension in essence means. And we have there's all kinds of theories. There are almost too many theories. So it's a little bit of a different kind of problem. I'm sure DeepMind would be helpful, but I would hope also that this guy from Nepal will learn how to do some introspection so he can monitor, and manage the process in the way that it needs to, that the machine itself cannot provide.
And interesting, I mentioned Nepal because introspection is a very big part of Buddhist mindfulness practice. And we in the West tend to underestimate it.
So I have questions for both of you from the chat.
Let's do it.
So for Lee, there's a question from Mark Goodkin. So according to Lee, do animals have free will? He said that to have consciousness is to have volition.
Okay, now please note that I did not pay Mark anything to raise this question. He did it strictly on his own, although I admit I kind of encouraged it by what I said. Yes, I think animals, my belief is that consciousness as a faculty, that the causal efficacy of consciousness is volition. That's what it is. That's why it evolved. And I've already recommended, but I'll do it again because I take any opportunity to do so. The article by myself and Monroe Trout called "What is Consciousness For?" you can get for free at New Ideas in Psychology, the journal New Ideas in Psychology. It was published in January of 2017. Just go online, you can get a free copy. Now, it's a controversial issue. The standard objectivist position, more or less, is that free will is a phenomenon of the conceptual level. And I would certainly agree that free will in its full-blown self-conscious application in its complete evolution is, but I insist that evolution doesn't work by suddenly producing that sort of thing out of nowhere. It doesn't work that way. That in fact, evolution goes through a number of transitional forms, and I believe some of them in this case, it went along with the evolution of consciousness, that even at the perceptual level, you yourself can notice that you can do things like you can move your head, you can move your eyes, you can even attend to something in the corner of your eye, which doesn't involve any movements at all. You can walk around objects and see them better by walking around them. You can pick up an object in your hand and manipulate it intentionally, volitionally, in a way that gives you much more perceptual information. All of these things are evident, I think, introspectively. So, this is a big argument, and Harry may want to chime in here since he doesn't agree. But yes, I think that it's by the nature of consciousness, and that's what our article is about, that consciousness is by nature. Otherwise, let me put it this way, if you were conscious and did not have some kind of volitional power to do something about what you're aware of, you would be a couch potato sitting there, and stuff would happen to you, and you wouldn't be able to do anything about it. It would be horrible. So it would be unimaginably awful to have a consciousness without free will, and I don't think anybody does, including animals. So I can go on about this all day, but let's go on to other things. Yes.
I have a question for Adam, and maybe it's a little bit technical, but you mentioned something about backpropagation, and you mentioned it as you were using the language of neural networks to refer to our actual brains. So you're saying back propagations is happening in our brains. So back propagation is, another word for it is reverse mode differentiation. And it's just a process of finding the gradient of the cost function. So it's the means by which you reduce the error of the network so that it gets closer to the truth. So do you actually think that that process is happening in the brain? Because the brain doesn't get a set of training data already marked with what it is in order for it
That's a
to
very good question,
do that
Adam.
process.
No, it has to
That's a good question,
acquire,
Adam.
yeah, it has to acquire that by action, by free action in the environment. That's where the experiment with the free kitten and the yoked kitten are very instructive, because it is the free kitten that can move around, make choices, and then in the brain, if the brain correctly predicts the outcome of a given motion that the free cat engages in, that will correct the error in the function that's transforming the input into the prediction of the output. If a cat is not free to move around, even if it's yoked to a cat that moves around and is making the same motion, the backpropagation process cannot take place. Did I answer the question?
Yeah. So you're saying that the process is, it makes a prediction, and if the prediction is wrong, it's like it's failed. That's like the cost function. That's like it's failed.
Exactly.
Okay. There's another question in the chat.
Before we go on,
yeah, go for it.
Before we go on to the next question, I see that Steve McBride has posted a URL for the What is Consciousness article, and that's for an older version, which I should replace. The newer version you find by going to go to New Ideas in Psychology and put in Pierson, or just put Pierson and Trout, Trout, into Google. Put Pierson and Trout, and then maybe What is Consciousness for, and you'll get the article that's at New Ideas in Psychology, which is the updated version, which is 10 years or so later version of the article. That's probably the better one to read.
So I'll read out another question in the chat, and I'll direct it to both of you. So Ella asks, I want to ask about computers' ability to differentiate and integrate. I think computers can differentiate much better than human beings, given their superior computational power. And differentiation is a mathematical process. On integration, this requires grouping multiple units sharing the same fundamental characteristic, giving it a name and storing it in memory. Technically, I think computers... So it's quite a long question. I'll get to the end of it.
Yeah, okay. Okay.
Technically, I think computers can still do it, but as it still seems mathematical to me. So it seems like computers can be as objective and creative thinkers as humans, given that we feed all the relevant information into it. The issue is just about resource. Is the issue just about resource?
I'd like to get my 2 cents before Adam puts his dollars worth. I want to get my 2 cents in on this one. This is a good question. Now, we start with we have to know what we're talking about. Differentiating, integrating. It's just like anything else the computer does. When the computer adds numbers, it's not really adding numbers. It's sitting there. Harry likes to make this point, but I heard it back in grad school from other professors. It's playing around with electrons. It's sorting electrons. what the computer is actually doing. So it's not really adding, and it's not. So when we talk about differentiating and integrating, I would say that's not really what the computer does, but it's doing something analogous to, or it's a simulation of, however you want to put it. And there is something about the difference between those two things that's interesting to me, because if you think about differentiating and integrating in calculus and mathematics, differential calculus is kind of mechanical and straightforward. You learn how to do. You learn, the procedures. They're out very quite algorithmic. At least for me, and maybe there are more advanced people that learned more than I did. Integration is a whole bunch of, a whole bunch of stuff is involved in doing integrations, and that it's hard or maybe impossible to reduce to an algorithm. It's at least a lot harder than differentiation, and it is precisely, I think, because differentiation, you're just splitting things up. Integration, you're putting all kinds of stuff together, and there are lots of ways of doing that. You might integrate with little tiny rectangles, or you might integrate using little tiny triangles. There's all kinds of things. So I think there's something to it, and I'll turn it over to Adam. But I think maybe Bob. It looks like Bob Stubblefield wants to chime in too.
The differentiation that we learn to do as animals is this better for me, or is this worse for me? And it is only at a very late stage when we learn to abstract differentiation as being not just good for me or bad for me, but having this quantity that is different, or this quantity that is smaller or larger. So it's in reverse. It's the more complicated, life-oriented differentiation that comes first, and that we probably get from evolution. And it is only much later that it becomes an abstract operation. And in all the abstract operations that I know of, integration then emerges as a reverse of differentiation. So it is two steps away removed from our biological differentiation by way of abstract differentiation, and then a reversal of abstract differentiation. Now, that doesn't mean that there's a limit to how much a machine can do it. In fact, a machine, if it's integrating, is not limited by our limited capacity, what objectivists call the crow, because crows can only have 3 attention pointers at a given time. In humans, it's the magic number 7 plus or minus 2. In other words, some people can pay attention and integrate up to 5 things or 7 things or 9 things. A deep learning computer does not have that limitation. And while I have not yet read the full technical details, I suspect that the reason humans did not solve the protein folding problem in 50 years of trying, and DeepMind solved it in just a few years, is that it does not have the limit of 7 plus or minus 2. Maybe it can consider 20 or 50 or 100 different things to pay attention to.
Let me just go back to Ella's questions. I just noticed something interesting at the end that I want to comment on. She says, so seems like a computer can be as objective and creative a thinker as human, given that we feed all the relevant information into it. Yeah, that's right. But you see that, well, it's sort of right. But the problem is that feeding all the relevant information into it is exactly what objectivity is about. You have to be objective to do that particular operation. So yeah, given that we are objective and feed the right information into it, the computer will work. But it doesn't mean that the computer becomes objective. The result may be objective, but it's because of our activity of identifying and feeding that relevant information, which doesn't happen automatically. And that can't be, I think, totally automatic. This relates. Someone brought up the issue of bias. One of possibly the most important kind of bias that Kahneman and Tversky and those guys identified as confirmation bias. And the answer to confirmation bias volitionally is always be on the, well, part of the answer. I can't give a full answer right now. Part of it is always be on the lookout for counterexamples, counter evidence to the conclusion that you are arriving at. Make sure that you consider all the evidence, including evidence against it, which doesn't happen, just as a matter of fact, does not happen for humans automatically. They often go away from that. That's why this bias shows up. But there is an answer to it, which is the proper use of volition. And if you develop the skill of doing that, you can avoid that bias.
Okay, talking about bias brings to mind irrationality. And that is, somebody asked me about possible dangers or evils in deep learning. And what this brings to mind is somebody like Putin. Now, you know that Putin likes to poison people, but he never poisons them twice in the same way. He always has his scientists, his biologists, come up with a new way to poison someone. So yes, there is a danger that a bad guy like Putin could program or have his engineers program a deep learning system to invent new ways of poisoning people. But remember, it's the wielder of the tool, not the tool, that is capable of evil and danger. And that's why we have to pay attention to who is using those tools.
So since
I
we
noticed
don't,
that, there's a comment from Harry Binswanger that I'd like to comment on, and he might want to join in. Harry in the chat says, consciousness is far wider than volitional consciousness. Of course that's true. That is to say, there are all sorts of things that we're conscious of that came into our awareness without, if you make a loud noise, I'm going to automatically pay attention to that. So that is true. My point is, however, that my argument is that the causal efficacy of consciousness is in volition. You have all kinds of conscious experiences that are not volitional. Those things matter. Why do those things matter? Because they lead, or they inform, or motivate, or provide a target for volitional attention. That's why my argument. So I'm certainly not denying that conscious experiences go far wider than volitional, the things that are conscious volitionally, if that's what Harry means. That's not a problem.
So we only have 10 minutes left. Doesn't seem like there's any more questions. So I'll ask a hopefully quick question. So,
okay.
So this relates to the brittleness of neural networks. So there's certain kinds of, one very good demonstration of the brittleness of neural networks is the so-called one pixel attack, which is you can take an image, change one pixel, and trick the network. I think one of you mentioned that cars, these self-driving cars can be confused by a bumper sticker. So
yeah, right.
Another problem in the process of training these networks is they can overfit. They can memorize the training data, and are they able to classify or answer the right question just for that training data? But then you give it a new example, and it gets confused. So doesn't this suggest, because of how brittle this is, doesn't this suggest that this is not the process that's happening in the brain? Wouldn't it suggest that this and also when you look at the maths of these networks, that it's quite simple. Doesn't this all suggest that there must be something else going on in the brain that is not reflected by these networks? So there's a question for both of you.
Yeah, that sounds right.
Adam, you're muted, by the way.
Okay, Adam, I'll go, and then Adam will go. I'm sure he's got something here. Yeah, I think that's right. It's not when I heard back propagation I'm thinking we don't really know exactly how the brain does what it does. First place, does it really work in the same way that that so-called neural networks work? No, we don't know that, and I don't think it could, because I don't think neural networks do what we do. And certainly, if you, I wouldn't limit to the brain here. I'd say consciousness and the brain together do something more, and enables us to approach this, I guess we could say, conceptually, rather than on a one pixel attack method. And what my understanding of how AI systems deal with this kind of issue, and my understanding, I've already said, is not as good as some of you guys, but my understanding is that they deal with these things by ingesting and processing huge amounts of data. So they can, they'll process it pixel by pixel if they have to do it that way, and huge amounts. Whereas we don't really do it that way. We have the ability to omit unnecessary measurements, things that don't matter, which is what underlies our conceptual thought process. So let's maybe Adam wants to jump in here.
Yes, because I do think we have a mechanism to get around the pixel problem, which is imagination. A child normally keeps imagining what things would be like if something were different, if this flower were red instead of yellow, if I wheel a truck not across the floor, but across the wall or the ceiling. In fact, if I put two cars together on a wall, would their collision have the same effect? And it probably wouldn't, because they also have other dimensions to go in. Imagination, I think, is our master tool to get out of the false correlation problem, and especially the one pixel difference, where what if the car that ran a red light were a police car instead of a convertible? What difference would it make, and so on. Imagination is extremely important, and I think imagination is what gets us out of those false minima.
So Jay has his hand raised. Hopefully it'll be very quick because we're almost at the end. So I'll unmute you, Jay. So you can unmute yourself, I think.
Done. Can you hear me?
Yep.
Okay, sorry for all the background noise. I'm going along at a pretty good clip here, running between construction sites. On the subject of learning and training data, one of the factors is continuous training data being input. There's a fascinating program that I recommend to everyone on this. It's from a year to a half ago. It was Tesla Autonomy Day, talking about just brilliant innovation in a customized chip for autonomous cars that Elon Musk's team spent 4 years creating. And of course, with his reputation, he can attract the top talent on earth if they're available, or they will be available for him with what he can offer. There were 4 people speaking for different aspects of how they're developing this. Part of it is they use somewhere between 500,000 and 1 million cars on the road to provide them data that they continually, with a human in the loop, interpret to create more training data and bias the training data for the purpose of differentiating what needs to be differentiated for safe autonomous driving. So again, I recommend that to everyone. It's just a brilliantly exciting show to see. And I did have a comment about the magic number that Adam brought up, the 7 plus or minus 2. You can look at it in the chat. It's just in the, I researched that at one point because we use it in my work, and that number came up only in the context of points on one scale. For the general case, it's more like 4 or 5. So that's what I wanted to mention. And thank you. This is good fun.
Yes, and I would like to second the Tesla video, because what Tesla is doing that we don't appreciate enough is that every Tesla vehicle has a computer module that can be replaced, so that as we learn more and invent more about using computers to control a car, if when it's worth it, we can just unplug the old module, plug in the new one, and you now have a car with completely new technology. And similarly, if all the Tesla cars on the road have learning experiences that can improve the parameters of the neural networks in the neural network section of that computer, that can be downloaded in real time, so that your car not only has the best available computer at the present time, but also the best data that has been gathered all over the world at the present time. And I think that's real genius.
So we are out of time. I just want to say quickly that we're out of time, by the way, for the YouTube stream. We will keep the Zoom call open for a little while longer. Next Monday, same time, 7 p.m. UK time, 2 p.m. Eastern, we have Craig Biddle and Douglas Murray on discussion, Discovering the Good, Morality and Where It Comes From. The Zoom call for that event is open to members of the Ayn Rand Center UK only. But there is it will be live on YouTube. If you are not a member, there is a link both on YouTube and now on Zoom as well. You'll also get to enjoy other members only perks, like 2 separate discussion groups that we have. One on fiction at the moment, We the Living, where this discussion is run by a member of the Ayn Rand Center UK, but we have Shoshana Milgram joining us for some of these sessions. We don't guarantee that she's going to be there every Friday, but she is there often. And Saturdays, we have discussions of Dr. Leonard Peikoff's courses. We're currently discussing the philosophy of objectivism, and we're joined by James Valiant for those sessions, which are run by Nikos. So consider becoming a member, and of course you'll be supporting our work. Memberships start at £10 a month. I want to thank Dr. Reed and Dr. Pierson and Eamon for chairing. Dr. Reed and Dr. Pierson, do you want to let us know where we can find more about your work?
Adam, go ahead, Adam.
Okay. I don't know about work because I don't have a separation between work and life in place. But you can follow me on Facebook. If there's something interesting in my life, I'll post about it.
I don't know about following work either. I should be doing more work than I do, but I already mentioned one paper. I would suggest to anybody, if they want to discuss any of these topics or have further questions that occur to them later, my email is Pierson, that's a different email. That one doesn't work. Here it is. It's Refocuser, REFOCUSER, refocuser@gmail.com. And if you want to, Shoshana's doing something there. She posted it. Okay, Shoshana, my boss, my boss and research staff posted the email, and I'm always happy to discuss anything to do with consciousness, free will, introspection. Those are my 3 main things. But also I'll add and the universe. So anything that anybody wants to talk about, feel free to email me with a question or comment. I'm interested to talk about stuff. And I want to thank Adam and Eamon for providing some technical depth. We didn't want to get into technicalities, but we wanted to have it at least covered that we're not just talking in outer space here. And Adam and Eamon were very helpful in that regard. And so thanks, gentlemen.
Eamon, is there anything you want to plug before we end the stream?
I'm good.
All right. So thank you, everybody, for joining us, and see you next week.
Thank you.
Thank you.